Good afternoon and welcome everyone to today's SpaceX Commercial Resupply Services 5 pre-launch news conference live from Kennedy Space Center in Florida. We're getting ready for the launch of Dragon and Falcon tomorrow morning at 6:20 a.m. Eastern Time. And here with us to talk about preparations and getting ready for the flight are, to my left, International Space Station Program Manager Mike Suffredini. To his left, Hans Koenigsmann, Vice President of Mission Assurance for SpaceX, and Major Perry Sweat from the United States Air Force 45th Weather Squadron. And we'll begin with some opening remarks, and then we'll be happy to take questions. Mr. Suffredini?
Good afternoon. It's great to be here on the first launch of the year to the International Space Station. SpaceX 5, of course, is carrying much-needed cargo to the orbiting outpost. The SpaceX folks have worked really closely with us this time. Of all the cargo on board, we have about 1.8 metric tons of pressurized cargo. I think that's the most we've crammed into a Dragon to date. And that's been with the help of the SpaceX folks have used quite a bit of ingenuity to help us put items in all the little cracks and crevices as we kind of lean on the Dragon vehicle to supply ISS here for the next little while until the orbital folks are flying again. This year, of course, is no different than any other year that I've been in this program. There's always major changes happening on board. And of course, now we have a full breadth of research going on as well. I know Julie and folks chatted with you about the research specifically, so I won't dwell on that. But the program is got a couple of major changes happening this year. The first one is we're configuring the vehicle to have docking again for the first time on ISS since shuttle retired. We call it the International Docking Adapter. We intend to have two on board the station, one in the forward port where shuttles used to dock, and then another one on the zenith port of Node 2. That work includes the two docking ports, rearranging the vehicle to move the pressurized multi-purpose module that is sitting on Node 1 nadir. We're going to move that to Node 3 forward. We're going to move PMA 3 off the end of Node 3 and put it on Node 2 zenith, so the other docking adapter can be put there. And then berthings will occur at Node 2 nadir and Node 1 nadir. In addition to the docking systems, we also have to install the targets necessary to allow the close in proximity operations to occur, and the communication systems. So we're going to have a different communication systems on board in order to allow command and control between the ISS and the approaching vehicles. So this is quite a bit of work. Our plan has always been to have a docking capability in place and operational by the end of 2015. We're still on track to do that. The first real steps you'll see us take, and Dragon is bringing up some of this hardware, is to these three EVAs that will occur once Dragon arrives and gets settled in. We have three EVAs that are going to start the reconfiguration work. Once the EVAs are complete, then at some point in the future we'll be ready to move the PMM whenever the ops team is ready to make that move, and that'll be the most obvious change until SpaceX 7 arrives with the first of the docking adapters that will be installed, and that one will be on Node 2 forward. So all that work is on track, and we'll have it all complete, as I said, by the end of this calendar year. That's the plan right now. In addition to that, of course, we have the very exciting one-year mission coming up, and it's that crew launches to the International Space Station. Scott and Mikhail will launch this March, at the end of this March, and begin their one-year increment on board ISS. And of course, that is a big step towards human exploration beyond low Earth orbit. We always talk about ISS being the first step. This is a pretty big part of that first step, is to do this one-year mission and study the effects it has. This is the first of several we hope to do over the next several years, and so we're looking forward to that as well. And so with that, I'll pass on to Hans, who will talk to you about SpaceX readiness.
Yeah, thank you very much. And Happy New Year, and really happy to be here for the first mission in 2015. Falcon 9, Flight 14, and for Dragon, it's actually the 7th flight, CRS-5. It's going to be I want to point out, I do expect attention on the first stage maneuvers and landing, but I do want to point out that the main mission is absolutely to get cargo to the station and to make sure that the station supply is steady and stable and reliable. And that SpaceX basically does everything they can to keep this up and make sure that you get all the cargo you need, whether it's experiments or supplies. As always, there's a mix of that on Dragon. There's also going to be external payloads. I think there's one external payload this time flying in the trunk. The trunk is the part below Dragon, and it's going to be extracted as part of the mission. I can talk about a little bit about the main mission here. It's essentially very similar to the last CS4 mission that we had in, I think it was September. Basically, first stage burn for you, what you see here when you sit on the launch site, it's going to be very similar. It's going to be a close to 3-minute burn. Then stage separation. You will see the second stage ignite if the weather is favorable. And you will see the second stage continue for another 7 minutes before we get into orbit. In orbit, it will take us 30 seconds priming and maneuvering until we deploy Dragon. There's nothing different from the last mission as far as you can tell from the outside. There's going to be some differences after that, and I get to that in a second. Before that, I continue with Dragon. Dragon continues for about 2 days. It's actually 44 hours on orbit maneuvering and phasing and height adjustments until it will be grappled by the station arm. Once it is berthed to the station, it will stay there for currently scheduled 30 days. About I think February 7 is the current release date, deploy date from the station, and then come back and get water in the Pacific, a couple 100 miles to the west of Long Beach. We will wait there with the boat and catch Dragon basically, and put it on the boat and bring it back to the harbor for further payload, down payload, in that case, processing. And that will then be the end of the mission. So when the first and the second stage separate, the first stage will continue, and it will continue on a secondary non-mission critical, I guess, experiment to some extent. It will turn around, it will perform what's called a boost back burn. That boost back burn brings the stage closer back in. It will then continue to just coast. And as it gets closer to the atmosphere, it will perform an entry burn. The entry burn will slow the stage down, and that reduces the loads on the stage. So it's supposed to bring the stage then through the atmosphere, and that will be followed by a landing burn, and the landing burn is targeted to a autonomous spaceport drone ship. That is the official word for it. So the drone ship sits there right now and is basically waiting for the mission to happen. That I'm pretty sure this will be very exciting. It's, as I said, it's an experiment. There's a certain likelihood that this will not work out right, that something will go wrong. It's the first time we try this. Nobody has ever tried that, to our knowledge. And so currently, Elon put a probability of 50% on this part, really as an experimental part, basically, of the mission. Again, it's not part of the mission. We will focus. The entire company worked very hard to make the ISS part and the ascent part and the cargo part happen. I just wanted to bring it up on the side because I guess you're probably interested in that too. I guess that's all I had.
Major?
All right, good afternoon. Well, after a warm weekend over the Space Coast, we are seeing that increased cloudiness and wind shift around from the south to the north associated with that cold front that has since moved into our area and slowed down over the central coast, over the central Florida area, I should say. As we get into, fortunately, that front will not stall out like the last one did, and will continue to slowly push to the south. And what that means is the cloudiness will decrease, the clouds will start to thin out, and that has allowed us to decrease our probability of violation from 40% that we had over the past couple of days to 30% as we do have now. We can go to the visible satellite shot, please. You can see those clouds little as the sun slowly starts to go down. You can see, you can still see the clouds there associated with the front. Again, they're slowly starting to move to the southeast, and we really won't see a good push of clouds move out until Wednesday and Thursday. That's when we'll really see that front make its way to the southeast. So for tomorrow morning, we are looking at scattered clouds in the lower levels and mid levels, and then in the upper levels will be mostly cloudy skies at about 24,000 feet. You can see right there the forecast, 2,000 feet scattered in the mid levels and broken about 24,000 feet. And the mid levels is really where we will be focused, is associated with the thick cloud rule. We'll be looking at clouds anywhere between 0 degrees and minus 20 degrees Celsius. And in this case, that's about 15 to 20,000 feet. So in that areas, we'll be looking for clouds over the launch pad, and seeing if the cloud, any part of that cloud deck is that's greater than 4,500 feet thick, is between 15 and 20,000 feet. Visibility, no issues. Winds will be out of the northeast at 5 to 10 miles an hour. No issues with weather, and temperature about 64 degrees. Again, 30% chance of violation associated with the thick cloud rule. If we can go to the Friday morning, if we happen to slip into Friday morning, really no issues with clouds. Our concern really becomes more of an issue with the flight through precip. When we see the onshore flow, and this isn't really a direct onshore flow, we're seeing more of a, with the north-northeast conditions, it's more of indirect onshore flow. We do increase our chances of rain showers in the morning, particularly in the morning, especially when we have 2 or 3 days of onshore flow. So that's what we're going to be really focused on, is the occasional shower coming across the launch pad, and the concern with the flight through precipitation. So again, winds will be out of the north-northeast, 5 to 10 miles an hour. And temperatures will be a little cooler as that front does finally make its way down to the south. Temperatures will be about 10 degrees cooler than we will see tomorrow morning, down to about the mid-50s, and only a 20% chance of violation. Anytime we have an instantaneous window, it does make it a little more dicey because we can't provide a clear time and things like that. So, but otherwise, like I said, chances are low for violation, looking at 30% for tomorrow morning and 20% for Friday morning. So looking forward to a great launch. Thank you.
Okay, thank you. All right, we'll take questions now. We have news media and social media members from the NASA Social here, as well as a couple of reporters on our phone bridge. And we also have opened up for online questions. If you're online, you're watching, Jason Townsend from NASA headquarters social media is here, and you can send questions to the hashtag AskNASA, and we will get to those. But we'll start off here. For folks, please wait for the microphone, state your name and affiliation, and to whom you're addressing your question. And let's start off with Marcia Dunn.
Hello, Marcia Dunn, Associated Press for Mr. Koenigsmann. I'd like to hear a little bit more about the experiment at the end of the flight. How close will the closest SpaceX employees be to the drone when all this is happening? How will you record it? Also, by what time do you expect touchdown to occur? And is this all pre-programmed, or will there be flight controllers being able to divert it if there is a problem of some sort?
So the first stage is subject to range control in terms of flight safety. So that much is clear. It has its own safety package basically on board. But there's no, the autonomous part on the spaceship indicates there's just nobody nearby on the boat, or within a certain safe distance. I want to say 10 miles, roughly, something like that, but I'm not sure about the number. It's a safe distance that basically I believe the range safety office tells us there's some analysis attached to it that this is a safe distance. So no employee or anybody else is nearby the landing site the spaceport drone ship. That's what keeps that safe. And I think you asked how we record this. We have cameras on the vehicle. We have telemetry on the vehicle, of course. There's going to be a telemetry boat nearby recording telemetry. We will not, I believe we may have real time, but we will likely not have real time information. And I want to point this out from the Cape. The landing site is basically over the horizon, and we have no direct connection. We lose the direct connection with the vehicle at one point in time, but we do record the data locally near the drone ship, so that we can recreate whatever happened then. Yeah.
How many minutes post
Oh,
launch
the
do you
time,
expect
yes,
touchdown?
of course. So the nominal shutdown of the first stage booster is 9 minutes after liftoff. It's actually just a little bit ahead of the Dragon deploy, and we will in the webcast we will focus on the Dragon and the main mission. Yeah.
Bill.
Bill Harwood with CBS with two questions. Hans, what kind of sea states can you hand? And maybe the weather gentleman can give us some sense of what the waves are wherever your drone ship is. And I have a question for Mike after that.
Yeah, I don't know the sea state numbers, but I heard the waves are currently 4 to 10 feet. And for the backup day, I heard numbers up to 14 feet. This is neither one is a problem for the autonomous spaceport drone ship. It's pretty heavy. It's a fairly heavy piece of metal. So and it has position correction so it doesn't drift away. It's actually very tight position control.
Thanks. And for Mike, given the incident with the orbital spacecraft, and you don't have them available for the rest of the year, or at least until the Atlas Centaur flies at some point, can you give us some sense of how your planning and strategy is for these resupply flights in the instance that you had a problem with SpaceX? I mean, I don't know if that makes any sense to you, but obviously you're single string now with supply ships. I'm just wondering how that plays into your planning strategy for these downstream flights and how important it is for SpaceX to keep a steady cadence here.
So that's answered in a couple ways. Long term, eventually we need to get the upmass back that we lost on the orbital flight, but that doesn't have to occur this year. We have made one change in our plan. We were trying to hold about a 6-month protection on orbit. So I had 6 months from one supply flight to another. We're probably going to dwindle that. It's probably going to dwindle down to close to about 4 months in order to fly the research hardware we want to do and all the other things that we want to set up. And so we're floating somewhere around that, depending on the consumable, between 4 and 6 months. So if something happened to SpaceX, we'd have to, figure out where we were and how quickly they could return to flight, and then we would react accordingly. But without your supply ships, you can't go on indefinitely on orbit.
Could you keep 6 people on board if you lost if SpaceX went down for any period of time?
Depends on the period of time. So we will attempt to keep the crew. The crew has enough supplies, including research, to continue to work for somewhere between 4 and 6 months, depending on what we did. So the decision we'd have to make is how quickly can SpaceX get back up, and then what can we do with our Russian colleagues with coordinating support they might supply, which we'll talk to them about. And then we'd have to look together about, okay, what's the right steps to take? Do we go ahead and let everybody go home until we're ready to resupply again, or do we step down to 3 crew? And I suspect that's what we would do if we had to, is we'd step down to 3 crew first. But the way we manage station is not to have to make those decisions immediately. So we have quite a bit of resources on board. We have quite a bit of time to work through the problem. There's any number of problems that can be recovered from pretty quickly and get right back to flight. And then we'd spend a lot of time with SpaceX about priorities and things like that. So you could work a number of scenarios, and we have, and as we've thought about what to do next, and some of them you can stay on orbit for a while, and others you may not be able to. But in all cases, we have plenty of time to decide what to do next, figure out what we're really dealing with, and then figure out how we want to react to it.
Irene.
Irene Klotz with Reuters. I have 2 questions for Hans. The first is, can you just tell us what happened with the hot fire test last month that didn't work? And also, considering that SpaceX has already done 2 soft lands on water, what is the challenge this time? Why aren't you guys kind of expressing more confidence that this will work? Thanks.
Yeah, so the static fire was a tad short. We expect it to be a little bit longer usually, and there are boards on the vehicle. We clipped one of them. We looked at the data, and we were on the fence. We decided just be cautious and repeat the static fire. So that's what happened then, I want to say on the 19th, a couple of days later. And by that time, we pretty much boxed ourselves against Christmas and holiday season. And so we decided to I guess, stand down and move everything into the next year. I personally, I mean, I came here a couple of days ago. The team is rested, super, sharp and fresh to go. And I really think this was a good move to repeat the static fire and give everybody a break before we continue with a rather busy launch schedule for this year. So I feel this was the right decision. The second question was what's the difference? Yeah. So in the past, we pretended the ocean is a landing pad, basically, and landed soft on there, and you're right. Those landings were actually very successful. They worked really nice. There's obviously the ocean is not a platform, and so it didn't. The fundamental difference is the limited size, I think, of the autonomous spaceboat drone ship. It's very difficult to hit a platform of that size, basically. And when you look at it on the ground, I think it's probably a very, very big platform, a big spaceport. But if you look at it from, I think, almost 150 or so miles up in suborbit, then it looks like a very, very small place to land on. So I think the position accuracy of that is just the primary challenge. In general, there's not a lot of room to maneuver. Everything has to be really working fine, and that's why we're really cautious. I want to also point out, I mean, the focus clearly is on the main mission here, CRS-5, cargo to the station, and so that's why we're very cautious in terms of stage 1 landing success.
Jim Siegel, I'm with the Celebration News. I have two questions. One first for Mike. Mike, in your opening comment, you made a comment about the fact that SpaceX will be delivering much needed cargo. And I was curious about what in particular is needed at this point up at the space station. Is it food? Is it water? Is it other kinds of things, the equipment? What would be most needed at this point?
Well, remember, Resupply assumed that we had another vehicle with about 2.5 metric tons. And so, as I said earlier, we were building up to about a 6-month supply. And so now we've consumed some more food before we started adding. So we're starting to erode into the 4-month that we don't want to erode into. So that was part of it, is to keep the consumables at a healthy level to give us wiggle room if should we need it. The other is some spare parts. So we lost a few spare parts, some of which we can't replace quickly, and so we're finishing them up and fly them on future flights, and some of which we were able to get ready and get on this flight. In particular, we wanted to make sure we had all the hardware we needed on board for these EVAs coming up as we start the first steps in reconfiguring the vehicle for docking.
And Hans, regarding the experiment that you were telling us about, I presume that the idea here is to try to figure out how to be able to reuse the rockets in the stage 1 and so on. And this is an experiment, I understand that, so we don't think that this is going to be a very important aspect of this mission. But on the other hand, how important is this idea of recycling the rockets to SpaceX's long-term strategy and trying to keep costs down?
Yeah, I think you said the key word. The key word is long-term. Obviously, if you were to fly and throw the airplane away after every trip you take, it's going to be expensive. And so if you carry this over to rockets, if you're able to reuse parts of the rocket, first stage, really, and the key is actually reusability that is easy. It does not involve taking the rocket apart and replacing a lot of parts here and there and putting new engines on. By that time, you're lost already, basically. But I think if you have reusability that, even just limited for a number of flights that is in the airplane, type category, you inspect it. That is the long-term vision, I think, that largely Elon drives into SpaceX. And honestly, if you do imagine that you can fly the stage 50 times, there will be costs associated with recovering the stage, but that is really the way to go in order to get costs on launches down. And yes, we try something different. In the past, there's been different methods to achieve reusability or landing. I feel like this is just another route that might actually looks very promising. Actually, I'm going to be super excited if this works. But at the same time, I don't want to distract from the main mission. I understand it's very important to get CS5 into orbit. Actually, much more important right now, and we work on this long-term goal, continuously.
We'll take a question over here, then we're going to take questions from Alan Boyle and James Dean before we check in with Jason Townsend, who's been monitoring the hashtag #AskNASA, and after that we'll go to the phone bridge and then come back here for questions. So.
Hi there, I'm Ian Bragg with NASA Social. This question's for Hans. Curious what the control burns landing on the autonomous spaceport drone ship. Are you using a significant amount of additional fuel? And if so, is this adding a lot more weight to the rocket? And how is that different from previous launches you've done?
It's actually not that different from the simulated landings on the surface. It's very close. It does use additional fuel on the overall sense. You got to keep some fuel on the first stage for that maneuver, but it's actually not that much. And there's some benefits you have. The stage is largely empty, so it's light after the main burn, after the ascent burn. And we actually, when we land, we only have one engine on, so it's somewhat favorable in that case. That the stage is actually, it's a big structure. There's no question. It's a pretty big structure, but overall, it is actually very light.
Alan.
Hi, Hans, I just wanted to kind of fill in some of the gaps that I had. Is there an abort sequence? Is there a scenario where you would say, let's do something different from the rocket, or maybe let's tweak the rocket instead of trying to pull off the experiment? And then is there going to be a real-time determination of how successful it was, or do you need to wait for the videotape?
I don't understand the first part of your question. Can you
The first part is you have the first stage separation, and then is there any scenario where you say we're not going to do the boost back?
No, it's automatic. It's on sequence. Basically, the rocket goes its way, so to speak. Yeah. There are decision points, but the rocket will nominally go through a timeline and perform the burns and maneuvers that pointed to the autonomous spaceport drone ship. So there's no decision there, unless, that's.
Okay.
And the second question?
The second question is, will you know in real time how well it worked?
I don't want to promise that, frankly. And the reason I won't is because it depends on internet connectivity to satellite and links that we don't always control. And we've seen them work mostly, but sometimes not. So we should have some indication, but I really don't want to promise that. If you just rely on range assets here, basically receiving antennas, no, you can't see it from here.
And then the last thing is, if it does work, what happens to that stage? How is it brought back?
It's going to be a huge celebration. The stage will be brought back to port and thoroughly inspected. Obviously, that a lot of our future decisions depend on how well that stage comes back, if there's any damage, and how we could improve thermal protection and stuff like that. Yeah, it will stay on the autonomous spaceport drone ship.
James.
James Dean, Florida Today. Hans, apologies, but continuing on this theme with just some additional clarifications, just regarding the differences in this one versus previous attempts or soft landings. You know, you have made some changes to the booster with the fins, right? I just wondered, how much of a difference do you expect that to be? I mean, 50-50 odds actually sounded pretty good to me for this first time. You referenced the. Maybe I'll just start there if I can. Follow up.
So you're right. We added grid fins to the vehicle. They're visible on the outside and they fold out. I guess like 5 minutes roughly into flight. The grid fins give us more range on the down part of the trajectory, and they allow us to keep the vehicle stable. So they save propellant, which we obviously need for the landing itself. So that is obviously one part of the uncertainty that we have. We've done analysis, we've done tests, but ultimately you need a flight test to verify how effective are those fins, how well do they work, do they maintain stability in terms of roll, pitch, and yaw on the vehicle, and all these things are. It is an experiment to some extent. 50%, I don't know. It's certainly for the type of experiment, I would agree with you. It's actually not too bad. But then obviously the main mission is so much more in reliability. It pales against that.
So you referenced the stability of the autonomous drone ship and the lightness of the booster.
Actually, I meant stability on the first stage itself.
I'm sorry. I'm sort of switching.
Mostly in terms of roll, pitch, and yaw on the stage one itself. And it's only this is only for the way back, basically. It's not for the way up. For the ascent part, nothing changed. This will look like the last launch.
The ship itself, just in reference to waves and so forth, you mentioned is pretty stable. And
yeah.
The stage is pretty light. If you stick the landing,
yes.
I mean, will the booster literally just stand there, or could it be
exactly.
blown over by a gust of wind? Or also, I was curious if you had a hard landing rather than a soft landing, would that be bad for the booster or for the ship or for both? yeah.
It's
which would it be worse for, the
hard landing
booster or
and
the
a partial
ship?
landing would be both bad. Yeah, the landing has to be perfect in order to actually just stand there and be safe on the ship. The ship is pretty big, so I don't expect waves unless they're really large to have any impact on the vehicle. Our analysis indicates the first stage will stand securely. It will then go, actually when it lands, it goes through a safing sequence. The boat nearby that will get closer then has control of the stage, so they can vent the stage, they can verify the stage is safe to go. Everything has been saved. And so we have an operational concept of operations, basically how to secure the stage then on the boat and tie it down and make sure that on the trip back to port nothing happens.
Okay. And I'm sorry, lastly, I know a lot depends on exactly what happens, but based on whatever plan you have nominally or sort of optimistically, how many times do you expect to, if you're able to pull off the landing, whenever that is, how often do you expect to try to do that before you might be ready to move to a landing on land?
This actually depends partially on the manifest. There might be situations where the drone ship landing is more favorable in terms of propellant, and there might be other situations where it might be favorable or possible to get back to land. So it really depends on the mission itself. If I recall correctly, that drone ship will be active for the next couple of launches then.
For range safety, have you committed to trying a certain number of times before they'll
No,
let you
there's
come
no-
back to land?
No. I mean, it's certainly safer the way we do it right now, and range safety is pretty happy about that too. So it's a good test before we get back to land.
Okay, Jason Townsend has been monitoring social media questions for people who are watching online and using the hashtag AskNASA. Jason, do you have any questions for us?
Indeed, there's actually several here. This first one comes from Twitter user Anthony, who's asking, this is for Hans here, if the first stage landing is successful, how long will it be before we see video? And dovetailing with that, Philip asks, when will we know the result live?
So the second question, will we know the results live? Probably not. There will be some delay. If we know the control room, then I'm pretty sure it's going to be out pretty soon. Yeah, but we might not know it immediately. And in terms of video, I want to say, if it goes well, by the end of the day, maybe something like that. It takes a while to transmit the video back, and that's another thing where the link has to work. So it might be a couple hours, day or two. We work as hard as we can to get this done. But yeah.
Wonderful. Next question here is from a Twitter user Douglas, who asks, would a single engine failure prevent the first stage recovery even if you could push Dragon onto orbit?
It depends. So it depends on the engine that fails. If it happens to be the engine we need for landing, that would be bad. But I do want to point out that actually has it would probably have no bearing at all for Dragon if he lose the landing engine. We need for the stage landing sequence, we need three specific engines. Currently, if one of those engines would fail, if the center engine would fail, that would certainly be a problem. But I'm not sure about the other two. We might be able to pull this off anyways. The 50-50 would go down.
This next question comes from a Twitter user Anthony, who asked, at what altitude and speed do you expect the grid fins to deploy?
They deploy. Oh gee, I know the time. I looked up the time, but I really didn't check the altitude. It's way out in the outside the atmosphere. So it's before we enter.
Wonderful. Next question comes from John on Twitter, who asks, did the drone ship move to the landing zone on its own? Was there a crew on board the drone ship while it was moving to the landing zone?
I don't think so. Well, actually, I don't know. I have to be correct. I mean, I don't know the details how we got the drone ship there. I know there's another boat with crew, and the drone ship, I'm not sure if there's any quarters on it or not. I don't think so.
Wonderful. And this last question here is from Brent, who asks, how do the people at NASA feel about SpaceX trying to land the first stage?
Well, that can't go to me. Or?
Well, it's from...
Yeah, why don't you
It's for me?
answer for me?
Good. Okay, the people at NASA are really interested in that. I don't know. I mean, I guess NASA wants to make sure that it doesn't get attention away from the main mission. I want to say that. That's just, and honestly, I see that I have the same interest. I want to make sure that the CRS-5 mission works perfectly and there's no impact to the mission at all. That's the main thing.
So Hans said it very well. We're extremely interested in the success of this flight in terms of getting cargo to ISS, but as an agency, we're also extremely proud of our affiliation with SpaceX and very excited about the steps they take to further space flight in general and reduce the cost of space flight. So this is an exciting time from our perspective as well.
Okay, we're going to go to the phone bridge now where we have two callers on hold. First, let's go to Jason Davis from the Planetary Society. Are you there, Jason?
Yeah, I'm here. Thank you. This is for Hans again, all about the barge. I wanted to know if you have a precise landing coordinates for the barge. It looked like it was about 200 miles east of Jacksonville, possibly. And then secondly, I wanted to see if you'd be willing to say how much the autonomous drone cost. Thank you.
Oh, okay. On the first one, the first question, all I comment is stay away. I really mean that. And on the second one, I don't know the cost, frankly. It's actually, I want to point out, it's not a barge. A barge has no propulsion. This vehicle has thrusters, and so it's a drone ship.
Okay, still on the phone bridge, Michael Balfour from Popular Mechanics.
Hi there. It's good to be here. Thank you for answering these questions. Hans, about the drone ship, can you give us a rough, just how far out it's going to be from the Florida coast, if not the actual coordinates? And also I wanted to just verify that you said it was about 9 minutes after launch that it's supposed to land. The first stage will land on the barge. Is that, on the drone ship, is that right?
Yes, that's correct. It's the nominal timeline shuts the engine down right around 9 minutes. And again, that's just a tad before the second stage shuts down. And I, on purpose, did not look exactly at the location. I know it's a couple hundred miles out in the ocean to be safe, basically. But I don't know the exact location, unfortunately.
Okay, back here for questions. Phil.
Hi, Phil Keating, Fox News. Hans, I'd like to return back to the landing on the autonomous drone ship, if you don't mind. First of all, is it sitting in the spot right now where you're hoping the rocket lands, or is it actually going to adjust at all tomorrow?
It picks a spot and it holds the spot. And it holds it very tightly.
Elon Musk has said the whole idea of not trashing the rocket into the ocean, but doing this reusability is akin to not buying a brand new 747 and throwing it away after one flight. So take us into the future where this is proven successfully. What are we looking at as the future of space exploration with rockets, that it could possibly land on the launch pad day of, restack and take off again, sort of like a commercial aircraft? I mean, what could it be?
I think that is the vision ultimately, to make this more like an aircraft operation, where the stage comes back, gets minimal service. Fundamentally, if you look at the aircraft industry, which is extremely a well-oiled machine by now, just simply because they have so many operations. And if you can get the number of operations up in the space industry, that basically is our vision and our goal, to have as many launches as possible, to make sure that we fully understand what happens on the way up and down, and address whatever needs to be addressed, but not more. And basically drive the cost down over the long range. I mean, this would have an impact on the entire industry if you for a moment assume this would be what you said, like one launch per day or something like that, or even more. You would fly spacecraft that wouldn't be that expensive anymore. You would take more risks, and you might have a week of supply on the station. So I think if this would work out, it would have a tremendous impact on the industry that I haven't really thought through personally. I'm pretty sure Elon did. So yeah,
go ahead.
Stuart Muddy, Interspace.net, and my question on the same subject is for Hans. Two questions, actually. One, on the return effort, will the center engine be burning continuously, or are there three separate ignition events?
It's three separate ignition events.
Okay.
So if you count the ascent too, it's actually then four, right?
Yeah. So. All right. And in the event you are successful, will you be coming back to Jacksonville or right down Main Street here into the turning basin?
I think it's Jacksonville.
Okay. Thank you.
Okay. Hold off for a second. I'll let Jimmy get around here for Irene in the front row.
Thanks. Irene Klotz with Reuters. For Mike, is there anything specifically that had to be added onto Dragon after the problem with the Antares? You mentioned some spacewalk equipment, I think. And for Hans, on another off topic, since you're being very open today, can you give us an update on Falcon Heavy flight this year, and just the overall SpaceX manifest for the year? Thanks.
So to answer your question, we made some changes. For the life of me, that was before Christmas. It's been a long holiday, but I can get that for you. But we did have to rearrange the manifests. Our SpaceX friends were very accommodating. There were some items we put off. There were some we took off a what we call a NORS tank, nitrogen oxygen resupply tank. We figured out from a logistics standpoint we didn't need that tank. It was going to fly with oxygen on board. And that freed up room to bring some other supplies, but specifically what we put on, I've forgotten now. But I can get that for you and supply it through these guys.
Marcia? I'm sorry.
I had a question for about Falcon Heavy and the manifest.
Okay, so the manifest is busy. On the bright side, unlike this will now include more launch sites. So Vandenberg will be more active. You will see the next mission is a mission called Discover, and it's actually currently at the end of January. There will be Dragon missions, Crew Dragon missions rather, like the paddleboard, for example. Falcon Heavy, I don't know where we are currently and how everything is coming together, but I know that a significant part of the company is working on Falcon Heavy and trying to get it out for the first flight. But I really don't have an update on the actual launch date. So,
Marcia?
Marcia Dunn, Associated Press, with two questions. Quick one for Hans. What will be the peak altitude of the first stage? I think you mentioned 150 miles, but I wasn't sure if that's as high as it will go. And then I had a question for Mike.
I don't. That's actually usually the altitude, roughly, but and I don't think the burns reduce the altitude that much. So it's probably a little bit lower than what I quoted here. I had to look up the number. I can get back to you on that.
Helpful, thank you. And for Mike, you mentioned that you plan to fly ultimately more one-year missions, and would you envision those being back to back to back? How many more over? How many do you envision? And do you have a stampede of astronauts who are willing to go up there for a solid year?
Oh, that's a loaded question, so I'll stay away from the stampede of astronauts. But the answer to the question is from a U.S. Life sciences perspective, they have come to us and said they thought it would be beneficial to have 12 one-year subjects. We have been talking to our partners about when the next one could occur, but we haven't agreed on that yet. So by definition, because of where we are in the cycle of selecting crews, certainly the next flight after Scott and Mikhail return home won't be one of those. It may very well wait all the way until we get to the commercial crew vehicle where we have more seats that we could dedicate to it. But we're trying to decide that very question now. But as a community, even outside the U.S., the life sciences folks across the partnership agree that more subjects would be good. They're trying to get enough subjects to know whether or not we've reached equilibrium at 6 months, or whether there's enough changes that tells you need to do more to know if you can go further than 1 year on orbit. So the whole point of the subjects, even though statistically speaking 12 isn't a huge number, it's enough to see if the curve is going to change. And if you can figure out if the curve's going to change or whether or not you've kind of stabilized, then you'll feel good about decisions you make in the future for how many months you can fly based on the evidence from station.
Bill?
Just a very quick question for Hans. How long does safing last before the crew can get on board the drone ship? And I was wondering, I assume the LOX boils off and vents. I wasn't sure about the RP-1. Is that whatever residual amounts there, does it just stay in the tank?
It stays in the tank, yeah. It's like any other airplane, basically. In that it's at the order of maybe 1 or 2 hours. Yeah.
Let's take a question over here.
My name's Brittany Kraft. I'm with the NASA Social attendees. I was curious if SpaceX will be considered at Wallops Island after everything gets back up and running.
You mean as a launch site?
Yes.
So we did originally trade launch sites, and we made the decision at the time that we go to the Cape and to Vandenberg and have a private launch site in in Texas. So no, we're not looking at Wallops at this point in time.
Let's go to the phone bridge for a follow-up question from Michael Balfour from Popular Mechanics. Michael?
I think I'm good. My questions are being answered. Thank you.
Okay, you bet. How about checking back in with Jason Townsend on where we are with questions coming in on the hashtag AskNASA?
Sure. This question comes from Twitter user Bo, who asks, I would like to know if there are plans to expand the ISS and or remove or replace sections.
Let's see, our Russian colleagues are considering an addition of 2 or 3 modules. That has not been finalized, but they have been talking about adding a power module and a laboratory module. The MLM, in fact, was supposed to fly this year, 2015, but it's now pushed into late 2017 or maybe later. There are other opportunities, perhaps, for modules to come to ISS. The Bigelow team is building a small demonstration module, inflatable module, that'll fly to ISS. It's not meant to stay permanently on board, but it is supposed to arrive as well on SpaceX 8, actually, and spend some time on the aft port of Node 3. And there could be other exploration type modules that might need to come to ISS for a short period of time for demonstration and checkout. So the size of station is set for the job that it has to do, but it's possible that modules could come based on supporting other research and technology efforts. And of course, as I mentioned, our Russian colleagues are looking at some potential additions as well.
Okay, wonderful. This other question here comes from Twitter user Ricky, who asks, so what exactly are you taking up there? Food, fuel?
Fuel, no. Food, clothing, supplies, research, and an exterior experiment for measuring aerosols in the atmosphere, which actually helps on the study of global warming. So we continue. That's kind of the standard fare. It's usually about 30% cruise supplies and food, 30% research, and the other 30% is spare parts.
James?
Thanks again. James Dean, Florida Today. Mike, I was wondering if you could touch on a plan to fly Cygnus on Atlas V, and just that being like a different configuration that hasn't been demonstrated like these other vehicles were. Were there any issues with that, or is it just like that, sort of proven rocket flying any other payload? And also for either you or Hans, just wondering, if SpaceX found itself in the exact same position, would you also look to Atlas V to fly a Dragon?
So you'd have to get the details from Orbital, but they have some experience with the Atlas design and flying their bus, which is the Cygnus is based on a bus that they use throughout their satellite fleet. And so that gives them great confidence that they can fly this spacecraft on board the Atlas. Of course, you have to adapt to it, and you have to do quite a bit of loads analysis to convince yourself you're okay. So we will look at all that to make sure that the environment won't damage our hardware. All the normal things we do to clear a Cygnus to approach ISS, it's the same spacecraft, so that normal work will be done, and that's not different than what we've done before. The only other thing we'd have to look at is the vehicle and how the interfaces to the vehicle. And understand that performance. Of course, it's an Atlas, and there's quite a bit of data on the Atlas vehicle itself. So in that respect, it won't be a huge amount of work. Probably the biggest thing that has to happen is they have to do all the environmental analysis to confirm that Cygnus will be okay and to help us know that the cargo inside will be fine. That's probably the biggest delta for us.
Okay, we're going to try to see if we can squeeze 3 more questions in. Let's go to the back of the room here.
Hi, I'm Justin Beaupre with NASA Social. Actually, I have a question regarding the weather for the autonomous spaceport drone ship. I don't know if you're working directly with them, but what kind of weather might we be seeing, as well as maybe what type of weather should we be worried about? Maybe that's more towards you, Hans, for the restrictions that they might have when coming in, because we're not entirely sure what to expect.
I'll give a quick rundown on the wave height forecast. Looking at wave heights for tomorrow morning to be about 5 to 7 feet, and then behind that front. And then they'll pick up, if we happen to slip into Friday, then waves will pick up on Thursday, will be a max of about 12 to 16 feet, and then they'll back down for Friday morning to about 6 to 8 feet. So I'll let Hans explain what his thresholds are for that.
So as I said, the drone ship is pretty big and those wave heights don't have any significant impact on the landing. And in terms of clouds, I don't think we have the same limitations that we have on the way on the ascent. I don't think there's a thick cloud rule on the way coming down. So there's a lot less limitations, honestly, in terms of landing.
Okay, here in the front row.
My name is Adam Byerly with NASA Social and NASAPix.org. I was wondering if you could tell us a little bit more about the actual process of capturing the Dragon spaceship to the International Space Station, how long that takes, the actual procedure, and how it may differ from other missions like this.
Is that to me or
to you?
Okay. Well, I guess it's an arbor. I think the R means radial approach in the sense that Dragon basically creeps up under the station over a period of, I think it's like maybe 6-7 hours. There's certain hold points in there. I want to say something at the order of several kilometers out. Once you enter the keep out sphere, there's going to be more hold points at 2.5, and so on and so forth. Every hold point you verify that you're good to go, you have all your redundancy still working, you got enough propellant, and so on and so forth. It's a very elaborate and cautious approach, I would say. The arbor has also certain advantages that if you lose total control at one time, you're not endangering the ISS at all. It's a very safe approach. It's not like tailgating basically. You would drop off if you lose control. So as you work your way up on the arbor, which takes a couple hours, you then stop at 10 meters basically, and once we got the go for capture, which is always a dramatic moment. I forgot actually the time. It's roughly 44 hours after launch, so it's going to be in the middle of the night instead of early morning. But once we get that command, Dragon basically decides not to do anything anymore. It isolates itself. It shuts down propellant so that there's no thruster firing when the station arm grapples it.
And so he flies. They're going to fly into a box,
right,
about 10 meters away from station, and as long as they're in the box, right, then as Hans says, at some point they go to free drift. The crew moves the latching end effector in to grabs the vehicle, and then rigidizes. Then at that point, actually, the ground commands the arm. The crew goes off and does other things. The ground commands the arm to put the Dragon over to the common berthing mechanism. At that point, the crew comes back. They operate the CBM in conjunction with the ground and attached to the station.
Hi, Val Phillips, Zero G News. I actually have a couple of questions. One for Hans, which is basically about the range around the autonomous spaceport drone. In respect of anything coming into it, which is like a ship that shouldn't be there, kind of thing. What's the issue in respect of will that just abort the attempt? And in respect of Mike, I was just wondering about any items within the Dragon which is related to the 1-year mission that's coming up, whether you're starting to stage materials up for the 2 crew members.
Should I go first?
Please.
Okay. So any ship going in between or getting too close, you would try to chase away. And it's obviously a safety issue. There's human life over something else, so you would chase it away.
And yes, Dragon has some of supplies for the 1-year mission. I think some of it's already up there, and then some of it comes up on Dragon. Some of it actually comes up on the vehicle that they fly on as well. So a portion of their supplies go up on the SpaceX 5.
Okay, I'm sorry that we didn't get to everyone's question, but we have to wrap it up and get ready for launch tomorrow morning. The exact liftoff time that we have now is 6:20 and 29 seconds a.m. Eastern Standard Time. Our NASA television coverage will begin at 5 a.m. And between now and then, you can keep up on any activities that occur by going to the website at www.nasa.gov/SpaceX. Thank you all very much.